Hey everyone, in this video we're going to take a LangChain agent and deploy it as a serverless API endpoint in the cloud. This means our agent will have its own URL ready to be called by anyone or any application we give it access to. This is a great way to share your LangChain agent with others and integrate it into larger applications. We will also set up a CICD pipeline to automatically deploy our code changes to the cloud once we push them to GitHub. Note that the example code we're going to look at in this video is available in a GitHub repository, which I will link in the video description below. Okay, let's get started. All right, let's look at our starting point. As an example to illustrate the process, we have a simple LangChain chain that takes a character and a job as inputs and creates a short story as output. First, we instantiate an OpenAI chat model, like GPT-4o Mini. Nothing fancy there. Then we've got a basic prompt template. Ours takes a character and a job to create a short story. We combine the prompt and the model into a simple chain using the pipe operator. This is standard LangChain stuff. Prompt goes in, LLM response comes out. We also have a function, let's call it invokeChain, that takes the inputs, makes sure the OpenAI API key is set as an environment variable, runs the chain with those inputs, and then prints and returns the generated story content. Finally, there is a standard if name equals main block just to test it locally by calling invokeChain with some example inputs. So far, so good. It runs locally. But how do we make it an API? We need a way to handle incoming web requests. For this, we'll use Flask, which, as I'm sure you know, is a popular lightweight web framework for Python. First step, naturally, is to install Flask. Just a quick pip install Flask. Now, let's modify our Python script. We'll import Flask components. We need Flask itself to create the application instance, request to access incoming data, and JSONify to send back responses in JSON format. Then, we'll create a Flask app instance, usually just app equals Flask name. Okay, now the core part is defining an HTTP route. We need an endpoint that the deployment platform expects. In our case, we will use a deployment platform called Atura, which expects a run endpoint that accepts post requests. So, we'll need to create this using the decorator at app.root. Next, inside the function tied to this route, we'll reuse most of our invokeChain logic. But instead of hard-coding inputs, we grab them from the incoming request's JSON payload using request.json. We should also add some basic checks to ensure the required inputs, like character and job in our case, are actually present in the request. We'll call our LangChain chain.invoke with these inputs. When our code ran locally, we just printed the result as a string. Here we also need to send the result back as an HTTP response. We'll wrap the story content in a JSON object using JSONify and return it. It's also good practice to include error handling, so we'll wrap the chain invocation in a try-except block and return a JSON error message with an appropriate HTTP status code, like 500 if something goes wrong. We can keep the if name equals main block, but instead of calling invokeChain directly, we'll use app.run to start the Flask development server locally for testing. Okay, our code now understands web requests, but the cloud environment needs to know which libraries to install. For that, we create a standard requirements.txt file. The easiest way is to run pip freeze. This command lists all the packages in our current environment, including LangChain, OpenAI, Flask, and their dependencies, and writes them to the requirements.txt file. Now, the final step before we can deploy, we need to get our code into a Git repository. If you haven't already, initialize a Git repo, add your modified main.py and the new requirements.txt. Commit them and push them to a GitHub repository. This is crucial because the deployment platform will pull the code directly from GitHub. With our code ready on GitHub, let's deploy it. As I mentioned, we'll use a platform called Atura here, which simplifies deploying agentic applications. This platform is a great choice for deploying LangChain agents and agentic apps in general. For one thing, this platform provides a simple way to deploy Flask apps and handle the underlying infrastructure. It also has a great CICD pipeline built in, so we can deploy our code changes to the cloud with a single push to GitHub. Finally, it has a generous free tier, so you can get started without any upfront costs. Okay, so next, we'll head to app.atura.ai and create a new agent project. If it's your first time using the platform, you'll be asked to connect your GitHub account. Here I have my GitHub account already connected, so all I need to do is to select the repository and the specific branch containing my LangChain agent code and hit deploy. Now the platform will pull your code, look at requirements.txt, install everything, and set up the serverless endpoint. This might take a couple of minutes. Okay, now the deployment is done. If everything went well, we'll see a screen like this. First, we can see that the platform has already created an API secret key for us. We'll need this key to authorize our request to the agent. So this key is important. Treat it like a password and keep it safe. And while we are here, let's also add any environment variables that our agent needs. For our example, we'll need to add the OpenAI API key. So let's add that. These environment variables will be injected automatically when our agent runs. Now we can proceed to the agent's dashboard. Here we can see the agent's unique URL for its endpoint, ending in /run. We can use this URL to trigger the agent. All right, deployment complete, environment variables set. Time to test it. We can use a tool like curl or any API client to send a post request to the /run URL we got earlier. Here I will use curl. The request needs a couple of things. The authorization header with your auto-generated API key as a bearer token. The content type header is set to application/JSON. The request body contains the inputs our LangChain agent expects, formatted as JSON. In our case, the character, curious cat, job, detective. Send that request. Now, because these can sometimes be longer running tasks, the platform will handle them asynchronously. So when we send this request, we will not get the output back immediately in the response. Instead, we'll get a 202 accepted status code and a JSON response containing a unique run ID, like so. This means the platform accepted our request and queued it for execution. So how do we get the result or check if it finished? The platform provides a way to check the status. There is a /status endpoint where we can make a GET request, passing the run ID. We'll use the same authorization header. This endpoint will tell us if the run is pending, running, completed, or failed. Note that we don't need to code this /status endpoint ourselves. The platform handles it for us out of the box. Alternatively, we can check the status and view logs directly in the platform's web dashboard. Go to your project, look for a Runs tab, and you should see the history of requests, their status, and any output your script printed, including our LLM-generated story print statement. This is super helpful for debugging. And one of the best parts about deploying from Git, updates are easy. If we want to change our prompt, use a different model, or add more logic, just update the code in main.py, commit the changes, and push them to the same GitHub branch we deployed from. The Itura platform will detect the changes and automatically redeploy the new version. Pretty neat CICD pipeline out of the box. So there you have it. We took a local LangChain script, wrapped it in a simple Flask API, added requirements, pushed it to GitHub, and deployed it to a serverless cloud platform. Now you have a scalable, accessible API endpoint for your LangChain agent. This pattern opens up a ton of possibilities for integrating your agents into larger applications or workflows. Hope this video was helpful. Let me know in the comments if you have any questions or what you're building with LangChain. Thanks for watching, and I'll see you in the next video.